All right, so now we're going to talk about the rate problems. These seem to be the most confusing, but once you get the hang of it, it'll make a lot more sense. And so Danny can do a particular job in 4 hours, and it takes Mike 6.5 hours to do the same job. How long will it take the boys to complete the job if they work together? Okay, and so the idea is we want to set up rational equations, which involves fractions. Okay, and so the idea that we're going to use here is that if we take Danny's, and we're working with hours, okay? So Danny's hourly rate, if you add that to Mike's hourly rate, you would get their rate together. Okay, and so you can't just say Danny's time plus Mike's time would equal their time together, because it doesn't make sense for Danny to take 4 hours and Mike to take 6.5 hours. They're going to get the job done faster if they work together. It's not going to take them 10.5 hours to do the job together. And so we can't just add the time plus time to get the total time. We have to add their rates, okay? Their hourly rates, since we're given hours. Okay, so if it takes Danny 4 hours to do the job, that means he's getting 1/4 of the job done every hour. Okay? So 1/4 of the job, and then after 4 hours, he'd have the whole job done. Mike's hourly rate is going to be 1/6.5 because it takes him 6.5 hours. I don't know how to say that as a fraction. 1/6.5 of the job is done after 1 hour. Okay, and so if we add that together, we would get their rate together. And so it's going to take them X hours to do it together. And so 1/x of the job is going to be done. Okay, and so now this is the equation we need to solve. Okay, so I'm going to clear this off so I have more room. Okay, so 1/4 is Danny's rate plus Mike's rate equals their rate together. Okay, so just like we've always done with rational equations, we have to get a common denominator across the board. Okay, and so they're all going to need an x. They're all going to need a 4. And they're all going to need the 6.5. Okay, and so our common denominator is 4 times 6.5 times x. Okay, and so now that we have that common denominator, we can ignore it. And so that leaves us with 6.5x plus 4x equals whatever 6.5 times 4 is, 26. Both of these have x's, so that's 10.5x equals 26. Divide by the 10.5. And we get about 2.476. And so to answer the question, we'll say 2.5 hours. Okay, and always double check to make sure that makes sense. If it takes Danny 4 hours and Mike 6.5 hours, it makes sense that it would only take 2.5 hours if they were working together. It should be less than either of their individual times. Okay, so I'm going to set up 7 and 8 for you and then let you solve that, and you can check that with the answer key. So Natalie can finish a 500-piece puzzle in about 8 hours. When Natalie and Renzo work together, they can finish the puzzle in about 4.5 hours. How long will it take Renzo to finish a 500-piece puzzle if he works by himself? Okay, so remember, we're going to take Natalie's rate plus Renzo's rate, and that's going to equal their rate together. These are rates. Okay, and so it says Natalie finishes it in 8 hours, so she's getting 1/8 done every hour. Remember, these are hourly rates because they gave us hours. And then when Natalie and Renzo work together, they can finish in 4.5 hours. So this time we're given their rate together. And we don't know Renzo's hourly rate. So we're going to put X. It's going to take Renzo X hours to do it by himself. And so that's what we're solving for. Okay. And then number 8, Julian can mulch a garden in 20 minutes. This time we're working with minutes. It's going to be the same idea though. Together, Julian and Remy can mulch the same garden in 11 minutes. How long will it take Remy to mulch the garden when he is working alone? Okay, so this time we're going to take Julian's minute rate per minute, and add it to Remy's rate per minute. And that's going to equal their together rate per minute. And so if it takes Julian 20 minutes, he's getting 1/20 of it done in 1 minute. We don't know how long it takes Remy, but together it's going to take them 11. Okay, and so in all of these equations, your numerator is always 1. Always 1 on top. And then the time you're given is always what's on bottom. Don't ever put X on top. I see a lot of students try to put X on top of the fraction. The numerator of all of these fractions is always going to be a 1.